for every move you're getting some reward. Okay, so here also there also in most of the gaming problems we follow this mechanism, what you call reinforcement learning. Okay, so this is one form of unsupervised learning. No doubt that we have somebody going to evaluate your actions, but that cannot be considered as a complete teacher. Okay, so we have three categories. One is supervised, unsupervised, and reinforcement learning. Okay. And similarly, we have different types of tasks. Some tasks we have already discussed, like pattern association, pattern recognition. Okay, all this leads to a sort of classification itself, function approximation, because whatever the types of mechanisms that we have discussed in back propagation of feed-forward networks, every time we are mapping X with Y. So there is nothing but a form of function approximation or robotic control, beam forming. So these are some of the list we have. Okay, no need to go in detail here. Okay. So this what about types of learning that I have missed. So apart from that, I have what you call uh, learning rules also, types of learning rules. Okay, so the second one, gradient descent learning rule, we have already discussed. So that is a form of supervised learning. Then error correction, so what you call withdraw of learning rule, so that is also supervised. Okay, delta learning rule, also called as supervised. Okay, this delta learning is something that we have already discussed in gradient descent when you're correcting or updating the weights. Okay, this delta rule and withdraw both are same. Error correction learning, there is also all these actually these slides I have received from Jaipur Action Center. This I have uploaded in your Microsoft team also. Okay, so you may find some mistakes. Okay, so here also you see all these are same: withdraw, delta rule, error correction, all three are same. All these we have already discussed when you're in back progression, where we try to minimize the error. Okay, by using that mean square formula. Okay, half of x y hat minus y whole square. Okay, summation. The same thing here also: withdraw, delta rule, error correction, all are same. Okay, so that we have used when you update the weights by gradient descent. Okay, so only difference we have here, the Hebbian learning, gradient descent, and all these three are same. Okay, so the Hebbian learning actually talks about when one neuron is close to another neuron, how that neuron takes responsibility of exciting the another neuron. So that is a phenomena based on which the Hebbian has coined a learning rule called Hebbian learning rule. How one neuron which is close to another neuron is going to excite. Okay, the neurons which are very far, they are not going to excite. The neurons which are very close in their vicinity, so they try to influence each other by exciting their electric potential. Okay, so that is what Hebbian has given. We call it as a Hebbian learning rule. Then gradient descent we have already discussed. This withdraw, delta rule, error correction, all these three are same. Okay. So these slides actually I've got from Jaipur Action Center. Just take a look. Okay. So there is an equation for weight updation in Hebbian learning. So we call it as Hebb's hypothesis. Okay, so this new weight is equal to old weight plus that change. So that change is nothing but learning rate, the output, and the corresponding input. Okay. So gradient descent we have already discussed. Let's see, this slides just go through that. Okay, this I have received from all this we have already discussed. This error correction. Error correction just compare the actual output with the desired output that you are getting. Okay. So reinforcement learning we have already discussed. Okay. So just go through these slides because this I have not prepared. This I received from the Jaipur Action Center. Just go through that. You'll get some more idea. Okay. You won't find much difference as far as the withdraw of rule, error correction rule is concerned. Okay. More or less they're all same. Here they have listed separately, but more or less they're all same. Okay. because you see they're all a form of supervised learning itself. Only the Hebbian learning rules are unsupervised. Okay, the rest you find that all supervised. Okay, so just take a look on the slides that I've already uploaded. Okay, if you have any difficulty understanding, just tell me. Plenty of information is given in this slide. Okay. So there is a general idea about types of learning, like supervised learning, unsupervised, and reinforcement learning. Just remember this. Pronouncing some alphabets, so the mother or the all this is not required. Okay. So if you have any doubt, respond to features contained in the. Otherwise, we will move to what we have, where we have stopped actually. Introduction to cloud computing. Okay. So last class, I just have given a brief introduction about cloud, why it is required. Just recap what we have discussed so far. Okay. So this was the scenario that last class we have discussed as far as the introductory part is concerned. Okay, before cloud computing, what we have done actually, for instance, if you want to host any website, then you have to buy servers. Okay, so if your website requires large number of data, then you have more number of servers is required for processing. So the cost is involved when you are establishing or hosting some website. Okay, so these are the things that you are going to uh, establish when you want to establish your own company or establish your own website or a server. Then cost is involved. Okay, for buying those servers. Okay, if a lot of processing is required, then more servers are required. Okay, similarly for storage also. So you buy a stack of servers, then again there is a cost in buying, there is a cost in maintaining and monitoring these servers. Okay, and there may be a probability of high traffic when there are more servers. Okay. So in that case, when lots of cost is involved as far as the infrastructure and maintenance is concerned, so now you just, instead of investing such huge amount of infrastructure or money or maintenance cost in that, we have a new environment called cloud. Okay. Where we are going to get the services on payment basis. Okay. So if you consider cost, then this setup is very expensive. You have to a lot of money is required as far as maintenance of those stack of servers are concerned. Okay. So the troubleshooting problems can be tedious and may conflict with your business goals, because every company has got their own business logic and business goals. So rather than focusing on that, they'll be always busy in troubleshooting or correcting their uh, or involving in the maintenance issues of their servers. Okay. And it's a tedious job and you have to hire people for that, and a lot of money is involved. Okay. So since the traffic is varying and your servers will be idle most of the time, okay, the best utilization may not be there. Okay, so when it is required, then only your servers will be active, otherwise it will remain as idle. Okay, but as far as the clouds are concerned or the data centers of Google, Flipkart, they are 24/7 busy. Okay, every time the server is going to process the information, they won't get idle situation. Okay. So in order to overcome such problems as far as the cost, the maintenance or traffic issues, so what we require is services. Okay. So we have files, we have music, we have ebooks, videos, applications, podcasts, everything is there as a service. Okay. So Google Drive acts as a service. Okay. Spotify or some other music sites are there. They are also as a cloud. Okay. Ebooks. Okay. This also acts as a service. For all these, even YouTube acts as a service. Okay. All these are nothing but they're acting as a service providers. Okay. You just create your own account, you get the service whenever it is required, then leave. Okay. So you don't find any permanent relation between you and the cloud, because whenever it is required, then only you're getting the services, otherwise not. Okay. And they charge for the services that they provide. Okay. So whether it's AWS or Flipkart, Amazon, all are nothing but the cloud providers. Okay. So why this is required? Because a lot of data is generated nowadays. Okay, whether your e-commerce data or satellite communication data or the mobile phones, Twitter, social sites. So huge amount of data is generated nowadays. Okay, so who is going to store the data? Who is going to maintain that data? Okay, because your laptop and mobile phone can't do this. Okay, so for that you require some third party, okay, who is going to maintain all this. Okay, so a lot of data, where to store it. So your hard disks are not feasible enough to store huge amount of videos or movies or books. Okay, so for that you require some other third party or a secure place where everything is there. Just you connect to that and get the services. Okay, so once your services is done, you discontinue from that. Okay, so this is what the cloud is all about. Okay, it acts as a service provider. Okay, so cloud computing is nothing but storing data or an application on remote servers. Okay, you are not having everything in your laptops or a mobile. For that you require an internet connectivity to get the access from what you call remote access. Okay, so you store the data, you process from the servers, access data whenever it is required by internet. Okay, so that's why here you see you can access these services from anywhere in the world. Okay, but it requires internet. Okay, so browser or a software, then here you have the cloud. So you connect to the internet and you can access. Okay, so this is what about cloud computing. They are nothing but a service providers. Okay, whether you want to use service as a storage, you want to use their processor to process your information. Okay, for every time you want the services, you require some sort of connectivity. Okay, so we have three different categories as far as the services are concerned. What you call service models. Okay, so whenever we talk about cloud is always nothing but service provider. Okay, so what type of services we want? Okay, so we want start right from software as a service. Okay, there are plenty of such examples nowadays. People are using the third party services. For instance, we have metal.com, which is generally used for examination purpose, is an examination software. Byju's classes, all these are nothing but they are working based on cloud. Okay, they are softwares. You just create an account, pay for that, and get the services through internet. Okay, so so cloud provider leaves applications or softwares which are owned by them. Okay, so you are not owning them. The third party are there. So Byju's is a third party. Okay, so Amazon Web Services is a third party. So they are going to provide you the services. You just pay for that. Okay. So cloud provider leaves applications or softwares which are owned by them to its client. So you are a client or you get their services. Okay. Similarly, if we have a Google Colab, okay, or a Google Drive, okay. So we have plenty of such commercial sites and financial sites. Okay. So for that, they just provide you the software by for that you have to create an account and you have to pay for that. Okay. For instance, we want to do a webinar and you want Cisco WebEx. So Cisco WebEx is nothing but a cloud. Okay, you just pay for to what duration you want that Cisco WebEx webinar software. You pay for 1 month or 1 year, and you just get the services from Cisco. Okay. So once the duration is over, the services will be stopped. So one example I have discussed last class also, the Salesforce.com provides the customer relation manager on a cloud infrastructure to its client. Okay, so this is the company who is going to provide that CRM software to their corresponding client, and they charge for that. But the software is owned by this company. Okay, so if you are using a software as a cloud, then you are not the owner. You are just a client. Okay, you are just using the software. Okay, you are just a customer and he is a vendor. Okay, so this is what you call software as a service, because when I say software means the application is stored in the cloud and you are just as a client, you are remotely accessing it through the internet. That's all. Okay. So if you have platform as a service. Okay, so far we have talked about application as software as a service. Okay, similarly we can have a platform as a service. Okay, so no control over the underlying architecture, including, for instance, operating system, storage, or servers. Okay, for instance, we talk about Google Colab. In Google Colab, you can use Python and you can use the processors. So there they will provide GPU 1, GPU 2, okay, high-end processing GPU cards to process your huge amount of information that you may get from satellite information or any other application related to data science, where huge amount of data is maybe a data coming from Twitter or a Facebook. Okay, so such huge amount of data cannot be processed by your desktop or a laptop or a mobile phone. Okay, for that you require a hardware, you require an infrastructure. Okay, you require a platform. Okay, you require an operating system. Okay, so that's why when you're using a platform as a service, okay, so there it may be an operating system, it may be a storage, or it may be a type of server or a GPU card. Okay, because those infrastructure you don't have in your vicinities. Neither you have in your laptop or you have in your mobile phone. Okay, but as far as these operating systems are concerned, for instance, if you have a Windows operating system and you want to use Solaris or Ubuntu and all, for that you have to install a virtual box. Okay, through virtual box you can install Windows operating system in your Ubuntu operating system on your Windows software. Okay, so that is what you are using a platform or an operating system from a Ubuntu on Windows through virtual toolbox. Okay, so that virtual toolbox has a interface. Okay, that is also an application which will help you to install a third party software on your Windows machine. Okay, so that is nothing but a platform. Okay, platform in most of the cases we generally call it as an operating system. Okay, so the cloud provider gives the ability to the customer to deploy customer created applications using programming languages, tools, etc. that are provided by the cloud provider. Okay, so you develop your Ubuntu applications. Okay, there are applications which are very much operating system specifics. Okay, they run only on a particular operating system like Unix or Ubuntu or Solaris. Okay, so in that case you can get that operating system from the cloud. Okay, so that is what you call a platform. You are getting a platform as a service from a third party because you don't have a platform in your laptop, because that requires a huge space. So you can get it from some third party. Okay, so whenever it is required you can use it. Similarly, infrastructure as a service. Okay, so infrastructure as a service, it provides virtualized computing resources over the internet. So here you see computing resources. Okay, so you require an infrastructure, maybe some hardware you require. Okay, so no worries about the underlying physical machine. Okay, so abstract the user from the physical machine. Okay, so the actual system is not there with you, but you have a virtual component of that at your site so that you can use it. So as I given an example of a virtual box, you can install a virtual box to install Ubuntu on your Windows machine. Okay, similarly in Microsoft also we have virtual Play Store. So there, from there also you can access the other operating systems. Okay, whether it's a Mac or Linux or Ubuntu. Okay, so that is what we call infrastructure as a service. So we have software as a service, we have operating system or a platform as a service. Similarly, we have infrastructure as a service where you don't have such infrastructure in your site, so you hire a third party as a service provider. Okay, okay, and for that you require a internet. Okay, whether you are accessing somebody's network, whether it's a router, any network components can be virtualized. Okay, not only the operating system. Okay, or the storage, you don't have an ample amount of storage, so you go for Google Colab storage. Okay, they will provide some amount of storage to you for your applications. Okay, so that's why we have three different categories like software, platform, and the entire infrastructure. Okay, so I have shown that block diagram the last class also. So when I say software as a service means you just focus on the application. Okay, for instance, so this data. Okay, so you want to manage your data. You have got huge amount of Twitter or a Facebook data, and you want to do some sort of data management. Okay, data science related processing. So in that case, you just require the data, and then the underlying software you get it from the third party. Okay, so that's why it is written managed by vendor. All these red colors are managed by the vendor. Okay, and you have only the data with you, and you want to use this entire underground infrastructure. Okay, so that's why application runtime, middleware, operating system, virtualization, servers, storage, everything you are using from the third party. Okay, you have only the data. Okay, so Google Colab is one such example where you write your Python applications. Okay, and the Google server is going to help you in providing these services: networking, storage, server, virtualization, operating system, middleware, runtime. Everything will be provided by the Google, but you have to run your application. Okay, so that is what you call software as a service. Okay, so a platform as a service. Here you see all these red colors. They are nothing but provided by the vendor. But what you require? You require a data and require applications that you want to execute. Okay, but you don't have a platform to execute, so you get this. Okay, so in software as a service, you are just hiring a software, but data is yours. You just get that software from this underlining vendor, use it, and get the result. Okay. So, but in this case, in platform as a service, so you have got the application and you have a data, but no doubt that you have got an application and data, but you don't have the required infrastructure to run your application. Okay, so you require an operating system, you require a runtime environment, you require virtualization servers, all this. Okay. So in the first case, when I say software as a service, you just have a data, and from application to networking, everything is from third party. So in the second class platform as a service, okay, so you have a data and you have an application that you have developed, but rest you don't have. So you use from the third party, platform as a service. Okay. So in the third category, you have your data, you have your application, you have your runtime operating system, but you don't have a desired server to manage huge amount of data. Okay, you don't have a huge amount of grid network, or a large network is not there. Okay, so for that, from virtualization, servers, storage, and networking, so this is not there with you, but the rest are there with you. So you use this red color resources from the third party. So that's why we call it as an infrastructure as a service. Okay, so we have three different categories, and this block diagram will help you in understanding what is required and where it is required. Okay. So here, as far as the deployment models are concerned, we have three different categories: public, private, and hybrid. Last class we have discussed. So public cloud. Okay. So publicly available, a service provider makes resources such as applications, storage, which is available to the general public over the internet. Okay. So easy and inexpensive setup because hardware, application, and bandwidth costs are covered by the provider. Okay. So no wastage resources because you pay for what you use. Okay, so this is what we have. So Google Colab is one such example. Your Google Drive. Okay, Amazon Web Services. So Amazon Web Services, you can get your account for 1 year, and then later they'll charge. Okay, so all there are nothing but examples of a public cloud. Publicly it is available. You have to create an account and you have to use the services that they provide. Okay, so that's why this diagram shows. So remotely you can access the services. So in private, okay, in private it is not open for everyone. Okay, so a company, two or three companies may have one particular private cloud. Okay, like that. So offers hosted services to a limited number of people behind firewall, so it minimizes the security concerns. Okay, so private cloud gives companies direct control over the data. So one or three companies, they have their own tie-up and they can set up their own private cloud, which is not accessed by any other third party. Only the employees of those companies can access. Okay. So there is an diagram it shows. So this is a private cloud. Okay, so it is not accessed by others. Okay. So hybrid, we have a combination of both. So here in the example I have shown in the figure, so So the combination of both you will find here a cloud computing environment which uses a mix of on-premise or private cloud and third-party public cloud services. Okay. So the combination of both private and public you will find in hybrid cloud. Okay. So it helps you leverage the best of both worlds. Okay. So whenever it is required, you go for public. Whenever it is required, you go for third party. Okay. Third party private cloud. Okay. So that's why this figure shows that. So all these three are nothing but the public, but there are some third party resource providers are also there with the servers. Okay, you can use not only public, you are using the combination of both public as well as private. Okay. So some examples I have shown last class also, and the most commonly and famous cloud providers is Amazon Web Services. Okay, so last class I have shown that in the Amazon Web Services we have different types of services we have. We just go through that. Okay. Then we have Google platform, Microsoft Azure. Okay, so we'll discuss this in detail when we talk about AWS or Microsoft Azure or Google Cloud. Okay, similarly we have IBM Blue Mix from IBM Cloud. Okay, so all these are nothing but they are the third party service providers. Okay. So this is what I've discussed in the last class. I just recapped that. Okay. Uh, so all this is possible because of one concept called virtualization. Okay. So when I say cloud always talks about virtualization. Okay, so without virtualization you can't do, because when I say that if you have a Windows Play Store, from Play Store you can get access of Linux environment or Ubuntu you can install. Otherwise, you download a software called VirtualBox. From there, you can install your Ubuntu on your Windows platform. Okay, all this is possible because of the virtualization or virtual creation of virtual machine. Okay, so why this is required? Because we don't have such amount of huge resources to run our own application. So that's why we required some third party who will help you to execute your applications which process huge amount of data, or lot of amount of storage is required, or a huge networking is required. Okay, so that you can't set up on your own, because a lot of maintenance cost or expense or a lot of cost is involved while establishing such requirements or getting such requirements. So that's why you depend on some third party called cloud. Okay, so in order to get the cloud services, the virtualization plays an important role. Okay, because when you're installing Ubuntu on your Windows operating system, so that is possible because of virtualization. Okay, so virtualization is a technique of how to separate a service from the underlying physical delivery of that service. Okay, so this why virtualization is required. So what it talks about? It talks about how to separate a service from the underlying physical delivery of that services. Okay, for instance, you have, as I mentioned, that you have installation of Windows 10 on your laptop and you want to install Ubuntu version 18 or 19. Okay, so and you don't have the required infrastructure on your machine. Okay, so what you will do, you download a software called VirtualBox. Okay, so then you install a Ubuntu. Okay, so what you are doing, that you are virtually providing the platform of Linux environment or Unix environment on your Windows software. So that is possible when you make your machine as a virtual machine by using any VMware or what you call any virtualization software called VirtualBox. Okay, so that's why it says that it's a technique of how to separate. Okay, I know that Google has got their own data center. Okay, but a copy of that I want on my system, a copy of operating system I want on my system virtually, because so when it is connected with the internet, then only you can use it, otherwise you not. Okay, so that virtualization is nothing but it brings the real system that is there somewhere in the Google data center or Amazon Web Service or maybe IBM Bluemix on their data center, but a copy of that will be sent on your local machine. Okay, so that is used, that will help you to establish connecting your system with the main data center that is there in the whether it's there in a Google Cloud or Amazon Web Service or IBM Bluemix, okay, or Microsoft Azure. Okay, so you are using their services on your machine virtually. Okay, so that is all possible through virtualization. Okay, so that's why virtualization is technique of how to separate service from the underlying physical delivery, because these services are there in the corresponding cloud service providers. Okay, you don't have that service. So for that, you make your machine as a virtual machine in order to access their services. Okay, so that is what we call virtualization. So it is a process of creating a virtual version of something like computer hardware. Okay, and it was initially developed during the mainframe. In the earlier era, uh, there is a concept called mainframe. Okay, where all the thin clients they used to access that mainframe whenever it is required. Okay, similarly here also the cloud service providers they will provide the entire service at your stride in your laptop or a mobile phone virtually. Okay, through internet connectivity. So it is a process of creating a virtual version of something like a computer hardware. You imagine that the entire cloud is nothing but a computer itself. Okay, somebody's computer you are using on your laptop. Okay, so for instance, I can, when you're sharing your screen, okay, I can share somebody's screen. All this is possible because of virtualization itself, because you are using somebody's machine, some other third party computers you are using. So the cloud means nothing but a computer itself, but that is not your computer. That is a third party computer that you are using. Okay. So in order to use that, you require virtualization. Okay. So that's why they mentioned that it is a process of creating a virtual version because the real system you don't have. So you want a copy of that. So it's a process of creating a virtual version of something like a computer hardware, and it was initially developed during the mainframe. Okay. So it involves using specialized software. One example that I have given, that virtual box or a Google Colab. So it involves using specialized software to create a virtual or a software created version of a computing resource rather than actual version of the same resource. So we are not using the actual system that is there existing in the cloud. We are just creating a copy of that on your machine, and the connectivity is established whenever internet is there. Okay. So that's why it involves using specialized software to create a virtual or a software created version of a computing resources rather than the actual version of the same resource. Okay, so we are not getting the actual versions, we are just getting a virtual copy of that. Okay, so with the help of virtualization, multiple operating systems, as I mentioned that in Windows you can use Solaris, you can use Ubuntu, you can have Red Hat Linux. Okay, so all this you can install on the same machine by using this virtualization itself. Okay, so multiple operating system and applications can run on the same machine and its same hardware at the same time, increasing the utilization and flexibility of the hardware. Okay, so the resources can be utilized at the high percentage level. Okay, so where this is not possible without cloud. Okay, so increasing the utilization and flexibility of the hardware. So in other words, one of the main cost effective hardware reducing and energy saving techniques used by cloud providers is virtualization. Okay, so this virtualization plays an important role as far as accessing services from the third party vendors are concerned. Okay, whether it's an exam software, whether it's a uh, Google Colab, whether it's a Google Drive. Okay, whether for instance if you have a Spotify or a music or a YouTube. Okay, they're all, their data centers and the service providers are maintained by their respective vendors. Okay, you are just accessing them as a service provider. You are a user and remotely you are accessing through the cloud, and that all possible because of virtualization. Okay. So virtualization allows you to share a single physical instance of a resource. So that's why I mentioned that a copy of that you are installing on your machine. Okay. So that's why allows to share a single physical instance of the resource or an application among multiple customers and organizations as one time. Okay, because you are not the only person who are accessing that service. Okay, there are millions of users who are accessing, so they are all creating a virtual system of the real system on their machine. Okay, but you will feel that you have the actual machine or a resource on your system, but in real thing it is not. Okay, it is there somewhere in the remote place, you are just accessing it through virtualization. So that virtualization allows you to share a physical instance of that resource. Why single physical instance? Because you have created one copy of that on your machine. Similarly, your friends are creating one more copy, so millions of copies are created by the same resource. Okay, so it does this by assigning a logical name to a physical storage and provides a pointer to that physical resource on demand. Okay, so if you're installing a virtual box and through that virtual box you are using a Ubuntu, so the IP address of your machine will act as one particular logical name or identification of your machine. Okay, so that will help you to connect to the actual remote server in the Linux. Okay, or Ubuntu server. Okay, so it does this by assigning a logical name to a physical storage and provide a pointer to the physical resource on demand. Okay, so on demand, whenever it is required, then only you can connect with that. Okay, otherwise not. For instance, if you're using a Google Colab and you have written a Python program, so once the program is run, after some time, if you are not using it, it will be disconnected from the cloud server. Okay, so again, you execute the program, it will establish a connection, you'll get the result. Okay, so everything is available on your machine when it is required, when you are using it. Otherwise, it is not available on your machine. Okay, so that's why it says that it does this by assigning a logical name to a physical storage and providing a pointer to that physical resource on demand. When it is required, then only. Otherwise, it is not. Okay, you are not connected to that service provider. So the term virtualization is often synonymous with hardware virtualization, which plays a fundamental role in efficiently delivering infrastructure as a service solutions for cloud computing. So as I mentioned that if you want to process some Twitter information or a Facebook or a huge amount of data, then your laptop, if you execute, it will take months to execute. Okay, so here that what you will do, you use a Google Colab, Google servers, okay, their GPU cards as an infrastructure through internet and get the results. Okay, so moreover, virtualization technologies provide a virtual environment for not only executing applications but also for storage. So Google Drive. Okay, Google Drive is nothing but a sort of virtual storage. Okay, so storage, memory, and networking. Okay, so these are some of the positives or the benefits we have as far as virtualization is concerned. It's more flexible and efficient allocation of the resources, enhance development productivity. You can create your own applications which will be executed by the cloud. It lowers the cost of IT infrastructure because you are not purchasing anything. Okay, you are using third party services. So remote access and rapid scalability. Okay, so remotely you are accessing and you can scalability means you can add more number of clients. Okay, high availability and disaster recovery, everything it is available, but it is require internet. Okay, so pay per use of the IT infrastructure on demand. Okay, enables running multiple operating systems. So in the same machine you can run multiple operating systems. Okay, so types of virtualization, we'll discuss this in the next class. So if you have any doubt, you can ask. Anybody having any doubt? So you just go through the slides for uh, neural slides of neural network. Okay, because I've got some slides from Jaipur Exchange Center as I mentioned. So you will get plenty of information there also. Okay, so you can go to that. Okay, you can go and check what other information is mentioned. Okay. So if you have any doubt, anything that you want to discuss, you can ask. Okay. I'll stop here. Thank you and take care.